Hello and welcome to my short presentation about the Luna 25 lander developed by the Russian space agency Roscosmos in light of my Planetary Exploration seminar. My talking points will be the history, that is to say I will talk about its development history, the history of the program the Luna 25 belongs to and its goals, and why it is called Luna 25 despite being the first lander of its program. Then I will detail the goals with a few short talking points. And then I will tell you about the science payload, that is to say the scientific instruments the Luna 25 lander was equipped with. And afterwards I will detail the results and compare them with the initial goals of the project. As I already stated before, my first talking point will be the history of the Luna 25 lander. Initially, the Luna 25 lander was called the Lunar Globe lander because it is part of the Lunar Globe program by Roscosmos, a program with the goal of building a fully robotic lunar base. Initial plans of the Lunar Globe lander were already being developed in 1997, but they experienced multiple delays. The largest and the first delay was from 1997 to 2012. Afterwards, it had to be delayed to 2014, then 15, then 16, then 18, then 19, and then finally it was able to be launched on the 11th August of 2023. Originally, the Luna 25 had already had also planned an orbiter in addition to the lander, but these plans had to be scrapped because of lacking resources. This lunar lander is the first lunar lander of Roscosmos, but not the first project of the space agency. The Lunar Globe lander was renamed to emphasize continuity with the Soviet space program LUNIC, or the Luna program as it was known in the Western media, which participated in the space race with NASA in the 1970s. After the Phobos grunt, also by Roscosmos, experienced a failure in Earth orbit, the plans of the Luna 25 lander were reworked. And after this, the design was finalized. Further delays, of course, were caused by resource pressure on the manufacturer. For example, the NPO Lavochkin provided the Weather Satellite Electro No. 2 and the Spectra AG Observatory. So it was lacking in resources to develop the Luna 25 lander. Initially, the ESA's, the European Space Agency's Pilot D, was planned to be included in the project, but after the Russians' invasion of Ukraine, they pulled out of the project and Russia had to replace it with a camera, with a commercial camera and not a specifically developed camera. Yes, the Luna 25 lander carried 30 kilograms of scientific instruments, which I will talk about later. and the whole project cost about 130 million from start to finish. After talking about its history, I will talk about its goals, all of which it has ideally met. But unfortunately, reality doesn't always meet your expectations. The first and most important goal of a lander is, of course, the landing. The landing location was planned near the South Pole, with the main landing point in the Boguslavsky crater and the reserve landing point in the Mancinus crater. The duration of the mission was planned to be 1 lunar year. And one of the goals, of course, is obviously the testing of the landing technology, but also the retrieval and analysis of soil samples and other scientific research raging experiment and the like. Next, of course, is the science payload, where I will detail the scientific instruments and the uses, that is to say, which kind of scientific experiments can be performed by which instruments. First is the ARIES-L, a wide-angle ion energy mass analyzer, which of course provides a measurement of ion parameters in a certain energy range, and can record the flux of neutral atoms from the lunar regolith. One of the features of this instrument, or one of the distinctive features of this instrument, is that it has an almost 360-degree view of its surroundings. In the framework of the Luna 25 mission, the task of the ARIES-L is the study of the interaction of the solar wind with the regolith, and the study of the regolith itself using secondary ion mass spectrometry and the determination of flux of neutral atoms. In this field of view, close to 360 degrees permits recording both of the fluxes of the solar wind ions and of course also of the secondary particles from the regolith, which makes it possible to study the processes of interaction between the charged particles of the regolith and the solar winds. And the secondary ability of the instrument is the measurement of magnetospheric plasma. The next scientific instrument is the so-called Hadron-LR, a neutron and gamma ray detector, which detects neutron and gamma rays in the soil in the regolith of the moon. And this measurement technique allows the development of models of the lunar soil depending on their hydrogen content, which can be used for the evaluation of water content and other major elements of planetary matter. Another scientific instrument is the LASMA-LR, the laser mass spectrometer, which enables the Luna 25 to carry out elemental and isotopic analysis of soil samples, which includes the regolith and the dust, with high accuracy and high spatial resolution. The principle of the device is based on complete atomization and ionization of the matter by a laser pulse and the separation of ions during their free expansion depending on their mass and charge. And of course a subsequent recording of the time of flight of ions from the target to the detector. As you can see, the device is quite small and has a mass of 2.8 kilogram. The sensitivity of the elemental analysis is at least 50 atoms per million in one spectrum, and scientific data obtained with the LASMA LR device can be used to solve a wide range of tasks, such as the geological characteristics of spacecraft landing sites, the analysis of lunar dust composition, the search for rare earth elements, native metal and alloys, and determination of the content of chemically bound water in regolith. And the solution of these tasks results in the study of fundamental issues related to the determination of the conditions for the formation and evolution of the moon, as well as the solution of a number of applied problems of its exploration. This instrument, the LES TV-RPM Lunar Infrared Spectrometer, is very important for the support of the robotic arm. It is intended for mineralogical analysis and assessment of the hydration of the lunar surface regolith near the lander, and it is designed to measure the spectrum of solar radiation reflected by the lunar surface, which will then be used to determine which soil samples can be gathered from the ground. The instrument has a support in terms of a television support stereo camera, which is called the TV RPM, which is also in the name, which functions in conjunction with the robotic arm. The PML, the Pilevoy Monitoring Luni, which is Russian translated to dust monitoring of the moon, includes impact and electrostatic sensors, which will be used to record individual microparticles above the lunar surface to measure and evaluate their physical characteristics like the momentum, the velocity, the charge, the mass, and concentration, as well as to monitor the dynamics of the parameters of the near-surface dusty plasma environment, as in the density, the temperature, and the potential. It does so also by measuring the impact of minor meteors. This scientific instrument, the STSL, which includes cameras and a processing unit, is of course used for video recording of the lunar surface at the stage of the main braking of the spacecraft, full panorama imaging during the descent and landing of the spacecraft, and during the work on the surface, stereoscopic imaging of the soil sampling area to build its 3D model. And in order to solve the problem of recording high contrast images on the lunar surface, the STSL provides a method of multi-exposure imaging with a high dynamic range. The article describes the interaction with the manipulator complex and the method of automated formation of closed panoramas. The Boonie is one of the most important instruments of the Lunar 25 because it is responsible for the operation of the other instruments, with exception of the STSL, the power supply, the control, the storage, and the transfer of scientific data, including the telemetry. Then one of the two instruments I couldn't find a picture for, the Thermo-L, which you can guess from the name is responsible for the measurement of the thermal properties of the regolith, and it also includes a laser retroflector, which is used for moon libation and raging experiments. And now to the final and most exciting talking point, the results. The launch of the Lunar 25 lander was on the 11th August of 2023 from the Vostochny Cosmodrome, and everything went as planned. The scheduled landing was supposed to be the 21st of August. Here you can see a photo taken with the STSL later on the 15th August. This shows, and this is a closer view of the Lunar 25. On the 16th of August, the Lunar 25 entered the orbit of the Moon. But when when they initiated the entering of the pre-landing orbit, they encountered problems. Yuri Brisov, the Director General of Roscosmos, said that the maneuvering engine could not be shut down. And then it ran too long, which resulted in the trajectory directly intersecting with the Moon. Here, these are other photographs taken by STSL after it entered the pre-landing orbit too early. But it was too late. Ultimately, the Lunar 25 lander crash landed in Ponte Color G crater on the 19th of August. Any attempts to re-establish contact on the 19th and 20th were unsuccessful. Here you can see the impact site of Lunar 25 before Lunar 25 impacted, and here you can say the impact site after the impact. The impact site is marked here in the middle of the picture. Yeah, we can see the initial goals again, so we can compare it more closely. Firstly, did it land near the South Pole? No, it landed in the southeastern part of the Moon. Did the mission last for 1 year? No, it lasted for 9 days. Were they able to test their landing technology? Well, not as planned, but it could be argued that they performed an unplanned stress test of the landing technology. And finally, did they retrieve and analyze any soil samples or perform any other scientific research? No. Overall, as you can see, the mission was a failure. I will now provide a look at my references, but don't worry, all of these links will be added to the description.